Hello.
Yes, sir.
Uh, am I audible?
Yes, you are audible.
How are all things? Gaurav?
It's going good.
Good. How are the assignments?
Assignments also going fine till now.
So that coding assignment was okay?
Yes, but actually I missed the last discussion, last to last discussion. So I saw it on YouTube.
Okay.
Actually, there was one problem
Mhm.
while finding the load point at Q known, Q known.
Mhm.
I think that was second or third question.
Okay.
The code was not giving the proper answer. Okay,
Okay.
but by hand calculation that was coming right, but
Okay.
from code it was not coming right. I don't know why.
I think the beam one, na?
Yes, yes,
Some
beam one.
some problem was there.
Yes.
Okay. No problem.
Apart
That's
from that, there was no problem.
the trust question was okay, na?
Yes, the trust problem was okay.
Uh,
Everything was right as per hand calculation, and
uh,
both were coming exactly the same.
okay.
But the beam, there was problem
Then there
in
was
the
problem.
formulation of Q known.
I'm
But
also not getting the exact result as the
yes,
assignment
hand
problem.
calculation are this is different.
Uh, okay.
There was some problem in the code.
Hmm. So let's start today's class.
Yeah, sure.
So I welcome you all to the TS session of NPTEL finite element method. Today is the week 7 class. Let's start. In today's class, I'll cover the assignment 6 solutions and all along with the questions of week number 7. So let's begin the question number 1. So the problem says, consider the following continuous Euler-Bernoulli beam and answer the following question number 1 and all. Each segment of the beam is discretized with single element. Global degree of freedoms are shown with red. Loading of the span is shown in figure and consider constant EI. You need to use the code which is given. So this is the beam which is given. So what we can see 1, 2, 3, 4, 5, 6, 7, 8. 8 degree of freedoms are there. Now the first question says, after assembling all stiffness matrices and force vectors, the equilibrium equation looks like this. So this is the general equilibrium equation which we know and we usually solve in the finite element method. So it is same. Then the terms are defined as UU as unknown degree of freedom, UK as known degree of freedom, and they are asking what will be the known force vector, and degree of freedom are arranged in ascending order as 4, 6, 7, 8. So what we can say, you see this 4, 6, 7 and 8. Now you have to find the Fk is the known force vector. So if you see each of the degree of freedom, this will be 1, which is u1 theta 1. Then this is 1, this is 2, 3, 4, 5, 6 and 7 and 8. So this will be u, what should I write? Actually confusing, so don't write like this. Okay, so what we can say, in the first degree of freedom, we know u is known. Similarly, because it is the fixed support. Similarly, in T, u is known. If you go to third degree of freedom, we know that u is known that it is 0. Similarly, if you see fourth degree of freedom, in this case we know some theta will come and u is unknown. So u is unknown in this case. For fifth, u is unknown. For sixth, u is known. For seventh and eighth, both u is unknown. Okay, so you know from where the we know u, we don't know the f. So similarly, we don't know what f or the reaction force is acting at this node, but we know that at 4, at 6, at 7 and 8, where we know we don't know the degree of freedom, we know the forces that are acting. So at 4 we can say it is minus 20 is acting in this direction, so it will give you minus 20. Similarly at 6, if you see no external force is there, so directly you can write 0. In 7, see minus 20 is there, and in 8 again 0. So if you see the answer which it will be answer number A. Okay, so since you have to solve this with the code as well, so I have taken the screenshot of the code. I'll explain you about the code, what it is saying. So initial the 2 and 3 line are the clearing the screen and the clear the variables of all. Now L is defining the length of the beam. So you can see 2 here and 2 here. So L is the length of beam. Then N is the number of element. Since we know 1, 2, 3, 4 nodes are there. So this is one element, this is one element, and this is one element. So we have 3 elements here. So N is the number of elements. And similarly we are finding the length of each element. So here it will be h is equal to L by n, which will be 6 by 3 equal to 2. So you see each of the length of the member is 2 meter. So this will give you as 2. Now we have to define the coordinate of the nodes. So what it has been done here, it will give you from 0 to 2 to 6. So it will give you 0, 2, 4, 6. You can see 4 nodes are there and each node coordinate is there. So first node coordinate is 0, 0, second is 2, 0, third is 4, 4, 0, and this is 6, 0. So 0, 2, 4, 6, you got the coordinate of each of the nodes. Now what you have to do, you have to form the element connectivity matrix. You have to tell the code which element is connected to which. So for that, what has been done, you are taking the first column of element matrix. Means if you want this, you are taking the first column of all this, and what you are getting, see, 1 is to length is to node, which is 4. So this is saying 1 from 1 to 1 till 3, and the next line says 2, 1 from 4 till 4. Okay, so what it will give you, the element matrix it will give you, and element matrix in the first column it will be 1, 1, then 1 to 3. So 1, 2, 3 it will be 1, 2, 3, but it should be, it will be 1. Oh, it will be it will go in row. So it is saying at one column and all of the row. So it will go to 1, 2, 3. Similarly, the second column is telling you the next node. So it will go to 2, 3, 4. If you see now what this element matrix is telling you, the first element is connected from 1 to 2, second is 2 to 3, third is 3 to 4. So you see all 3 elements, it is 1 to 2, 2 to 3, and 2 to and 3 to 4, 3 to 4. So these 3 members are connected by this elemental matrix. Now the basic things, now let's calculate. So you are calculating in here the number of nodes. So total length of the node, which will be 4, will go to number of nodes. Similarly, we are calculating how many elements are there in number of elements, and since each of the element will have a 2 degree of freedoms, so we are just multiplying number of node with 2 and getting the total number of degree of freedoms of our problem. So this is the initial part done. Then what we have to do, we have to initialize the properties of the material. So since it is not defined in the problem, we generally take 1. However, E and I are not 1. If you put that 1, we will get the higher deflections, maybe in the power of 100 or some, but usually it is into 10 to the power 5. So the deflection which we observe is very less, and which should also be. So for initializing, we can take E and I 1. What it is saying? It is saying for number of elements, means how many total numbers are there, which are 3. So each element E will be 1. For each element I will be 1. So that will be utilized in our problem. Now you have to define the boundary condition of your beam. So the first 1, 2, 3 The first column defines the node number at which the boundary conditions are applied. So boundary conditions where it is applied, it is applied at first node, second node, and third node. The fourth node has no boundary conditions as there is no external support. So we have mentioned 1, 2, 3 as the three of the boundary conditions, and in the second column we define if any transverse load is there. If rotation is there, we define it in the second column. So for if it is constant, we'll put it at 0. If it is not constant, we'll put it as 1. So if you see in the first node, which is this, you see this is also constant in this direction, also it is constant in this direction also. So that's why it is constant in both directions, so we'll put 0 0 in both. In second node we see 0 and 1. Why we see 0 and 1? Because we have restricted the member in this direction, but it can freely rotate in four direction. So it is 0 and 1. Similarly, in the third node also the same, this loading is there where we prevent this load, but this is freely moved. So 0 is constant and y is freely moved. So we have defined the boundary conditions on each of the nodes. Now we have to tell the program that how many external forces are being applied. So we are defining it with q vector, and the first column here again is the node number, second is the if shear force is acting, third is the if any moment is acting. So we see at node number 2 and 4, in node number 1 there is no external force. Node number 2 we can see there is no shear force, but we can see that one minus 20 kilonewton per meter moment is there. In node 3 there is no force or any external, and in node number 4 we see an external load of 20 kilonewton. So in the same way we have written here in node number 2, node number 4, and shear force is 0, moment is minus 20. In node number 4, minus 20 is the loading applied in the shear form, and 0 is the no external force. Also we have to define one more term, which is the UDL, which is acting here, which is 5 kilonewton per meter. So directly we can write here minus 5, and it will be distributed with what we'll do in the next step. So till now we have given all the inputs which are given in the problem. Now what we have to do, we have to initialize the problem variables for solving the problem. So we see initially we are initializing u, k, g and f. So what is the purpose of initializing these as 0 is that when MATLAB gets the defined what you say is size of the variable, it works very fast. Otherwise, if you don't put these zeros again and again, when loop will work, the MATLAB will change the size of the variable and it gets slow. So it's better to initialize any variable which you are using beforehand, so that MATLAB beforehand gets the size of it, and the process is very fast. Just it changes the values of 0 and compute the things. So all these things, the size of the u will be a degree of freedom, means if this is 1, we know u1 to u8 we have. So what are 8? 8 are the 2 into number of nodes, which is number of degree of freedoms. Okay, so directly you can write 2 into number of nodes into 1. Similarly, same size with a matrix, k matrix have it, so we have written like this. And similarly, as u, we know the same size f will have, so 2 into number of nodes into 1 comma 1. Okay, now you have initialized these basic matrices. Now you have to convert this q what we have, q we have in form of this, but we require f as this vector. So now what we will do, we'll make it like that. So how it has been done, we are running this loop for size of q, where what size of q is here, size of q we see is 2, because two forces we are at two nodes forces are being acting, so the size of q is 2. So this loop will run till 1 to 2. Now we have initialized j as qi. So j will be in first loop, it will be q1. Q1, what it is defining? Q1 is defining at what node the force is acting, that may be 2 or 4. So in the first loop, j will be 2, which is telling at which node the load is acting. And you see, at the node which is acting, one means, let's say if it is acting in the second node, one is this degree of freedom, second is this degree of freedom. So for this 1 2 and 3 4, if you are seeing the node is 2, means if you see the node is 2, the degree of freedoms are 3 and 4, which means uh, it is 2 into, it can be written as 2 into 2 minus 1 and 2 into 2, 2 into 2, which is 3 and 4. Similarly, they have defined here 2j minus 1 and 2j. So now if you have the node number 2, you will enter into the third degree of freedom and fourth degree of freedom as the q of the third value, means 2 to 3, means qi. This value you can put in this and you will get a f vector in form of all degree of freedoms. Okay, now what you have to do, you have to initialize the boundary conditions, and we have to find which all degree of freedoms are known and which all are unknown. So what we are doing, we are doing a same things now. Since we have to work in the boundary conditions, we are applying the loop on the boundary conditions, same as we did here. And again, as we have introduced these two terms, here we are initializing I1 and I2 in the same way. If our node is will be 2, the degree of freedom will be 3 and 4. Similarly, that value, that index will go in I1 and I2. Now what we have to check, if that boundary condition is equal to 0. This means if this boundary condition is 0, means it is constrained, then we can directly say that this index is known. So it will go into iduk, means displacement which is known. So we have gathered all the displacement indices which we know. Known displacement indices are being stored in iduk. Similarly, if other is 0, then also that is stored in iduk. So these are the indices I1 and I2 that are stored in iduk. In the same way, we have to find the iduu, which is the unknown degree of freedom, which directly can be now when you have the unknown indices, you can directly get the other degree of freedom as well. So we will run the loop for number of degree of freedom, and we will find if this is unknown, then so what find will do, it will give you a value of 0 or 1. So if 1 is there, this means this condition is satisfied. If not, then it will give 0. So when this condition is satisfied, means that degree of freedom which has the uk, you don't have to do anything. It will give as 1, and 1 will go here, and nothing you have to do, just you have to increase the loop number. But if this is not found, it will put the indices in the iduu. So now you have iduk and iduu as two of the vectors where you would have defined the indices for unknown displacement and known displacements. Okay. Now what we are doing, we are partitioning the stiffness matrices. So since we have the indices, we have distributed the KKU and KUU accordingly. Now let's solve the matrices for one of the element, and we can make it as as a global. So this I1 I2, we are working for the first element. For h, we are calculating the length of the each of the element. We have calculated h here as well. but this is only valid if each of the length have is having the each of the element is having the same length. Otherwise, if all the elements are having the different length, you will have to use this formula where absolute value of the coordinates will be get subtracted, and you will get the correct length of each of the element. Now what this is, this is the k element, which is, you have to already know, ai by l cube and 12 and all. So directly it will calculate the k matrix of one element. And similarly, this is the force vector what you write for fx into h by 2 and wl by 2. And what you get in this, when you have a udl, and you get the, this is wl by 2, this is wl by 2, and you get one more reaction here. So similar thing you all have studied in the class. So this is the distributed load vector, and the total degree of freedom for each of the element will be calculated by this. So when you so you calculate by calculating each of the elemental thing, you will assemble this matrix. This can be done in different ways. One of the ways is shown here, and you can directly use this and solve it. So while solving, you don't have to do a inverse b, because means k inverse u, because MATLAB is very slow in calculating inverse of any matrix. So what directly the function which is inbuilt in the inbuilt in the MATLAB is linsolve. So it what it do is directly solve you k inverse f. You don't have to write k inverse or solve for inverse of this matrix and then multiply. Directly it can solve you and give the solution in less time. So you can use linsolve, and you can get the different u for it. And if you want to distribute it, we can do it by each of the node as wi and theta. We can distribute it. So if you talk about the questions, the first question was covered, it was theoretical. The If you see the code, I'll share the code results. Okay, can you see the code? Is it visible, MATLAB?
Yes, yes.
Okay. So I have this similar code. I'll run it. Now what they have asked the what is the rotation at joint B and C. So for rotation we'll go to theta, and the value is 12.62. So it is given in the solution. And joint C also it is asked. So joint C will be this, which is minus 30.4. So which is in the solution. I don't know why minus and some sign is a problem for this. So I don't know for about that. The third question what it says is the reaction force at joint B and C. So reaction force can be computed, is computed here. I think reaction, no, not this. Reaction will be calculated by F unknown. So these are the reaction forces. So at C it will be 55, and one will be 41. So at B and C. So this can be done. Now back to the, So the I'll write the answer which I got from the code. It was 12.62 and minus 30.48. I don't know what answer they have given, but the one minus is missing somewhere. And if you see the question number 4 solution, uh, it will be question number 4 is 13.92. Means you have to see the it was coming 55 and 44. So, oh, is it repeated? This is 12.62 and minus 30.48. Okay, then this came to be minus 13.92. Maybe some problem in my code as well. Okay, let's solve the next problem. This code is working fine. So in this question, what you have been given, we have to consider the following truss. The two loads are given, and you have to solve the question. So I'll discuss the code here as well. So what it is done? First thing, we have to define the nodes. All the nodes which are there means 0040. These are the coordinates of the nodes of means 0040, 80, 12. You have to go like this and then return like this. So in the same way you have to do full problem. Since you have defined the nodes, now you have to define the elements which are connected. Means you see 1 and 2 are connected, then 2 and 3 are connected. Similarly, now in the end when you go after 12 is you have to define means 1 to 2, 2 to 3, 2 to 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now after 12 you see 12 is connected to 1. So you have shown here 12 to 1. Now extra members are there. You have to mention that as well. So 2 is connected to 12. Similarly, 3 is connected to 11. This also you have to give it all the elements so that code knows how many elements are connected with it. Now similarly the we have calculated the number of nodes, number of elements, and number of degree of freedom by multiplying the 2 into number of nodes. And you are initializing the material property E and A as 1. So boundary conditions. Now two boundary conditions are there. One is at node 1, one it has node 7. So both are 0 0 means constraint. So I have mentioned 1 and 7 as 0 0. External forces are acting on, let's see which node, which is 1 2 3 4 5 6 7 8th one, 9 10th 11th. So 8th and 9th we have mentioned as minus 50 and minus 100. It is in the y direction, so the second column has been entered. And now we are initializing the u and kg as 0, and the similar as the last problem, now we are converting the f in terms of degree of freedoms. Similarly, we are finding the indices of the unknown forces and the known forces as well. So the solving part is also same. I'll discuss the code and show you the results. Okay, is it visible? The MATLAB is visible.
Yes, sir.
Okay. Okay. So I'll run the truss problem and see. Now what this curve is showing, the blue one is the original truss, and you see the red one is the deflected after the loading is being applied. Now you can see the truss is deflected too much, which is not the original case. So why it is happening like this? Can anyone tell?
I think because the value of E and A and these are given very much.
Yes, yes, yes.
Oh, that's why.
That's why, because you
That's why
in
it's getting empty. Five.
yes, yes, E and I generally are not one. So since
I
you are
think A
having
and E because this is trust.
since we have given it as one, so it will show you the bigger displacements. So all this is done. Now the what question is asking you, it is asking the member force EF, force in the member force. So it is defined MF here. So each member, it is defined. So EF is the member number, I think 1 2 3 4. It is no, it is third one. So you will get the value as 4.17. Means each of the member, you can see you have all the members, you have all the forces. So since you have uh, this, now I'll ask you one more question. Tell me, without observing or without seeing the solution, which all the members will have the zero forces.
So can you repeat the question once? I didn't get it.
Without seeing the solution, can you to tell me which all members will have a zero force?
Yes, the shorter vertical members
Yeah, this
will
one
be the
and this
most.
one. Okay, I think it should be this. No, let's see the solution. This the vertical members. So when you see the result as well, you see, no, this is member. Huh. You see, this is 0, 17 1, 13 is 0, 2 are 0. So I think this is the 13 and the 17 member which are having the zero forces. Okay, the next after you have to see the horizontal support reaction at support A. So support reaction you have to see by F unknowns. So if you see F unknown variable, you will see four values are there because you have two nodes with the support reactions. So x direction, y direction, all can be computed here. Means all are computed here. So whatever is being asked, you can get from here. In the seventh question, it is asked the downward vertical deflection of joint D. So for that, you want to know the U unknowns. So for U unknowns, you will get the fifth member, which is 5, which is the solution. So all this is being asked, and you can directly get uh, from the code. Okay.
But what about the problem that I asked you in the beam?
Beam
The load.
beam with the load or the I
In the
also
load,
got
in the first question that you solved, no? From the code, I was not getting correct answer. I
same
don't know
same
why.
same. I also said the code. I am also not getting the correct answer. Maybe something is wrong in the code.
You could check it and maybe later share us the correct
Sure.
one.
If I get, I'll share it. Okay. So the answer which you have got for this is 4.17. For the sixth one is 70.83, and for seventh question it is 5. Since they have mentioned A, so directly you can, yeah, substitute A as 1 and you can get the solution. Okay, so the question number 8 was this, the identify the incorrect statement. So the first part is trust members can carry axial load only. Yes, you know this is correct. The transformation matrix is orthogonal in nature. So you know when you write the transformation matrix, you know this property is okay. So this is orthogonal in nature. For a two-noded frame element, the size of a stiffness matrix is 6 by 6. So if two-noded element will be there, which is a frame, you will have this also, you will have this also, and you will have this also. So 3 here, Similarly, 1, 2, 3, 3 here, to total 6. So you will get a 6 cross 6 matrix. So this is also correct. So the next is saying stiffness matrix invertible. Um the thing is, stiffness matrix, when you make it as reduced stiffness matrix, that is invertible, but regular stiffness matrix is non-invertible. So D is the answer, which is incorrect. So question number 9, which says after assembling all these stiffness matrices and force vectors, the equilibrium equation looks like this. Yeah, you know all this. uh, so UU is known, freedom UK is unknown, and you have to find the size of this. Okay, it's not tough. You know, for the node number 1, which is degree of freedom 1 and 2, you know this is U known. This is U known, as you know that they can't move. Similarly, U3 is known, but U4 you don't know, unknown. U5, U6 are also known because you know the boundary conditions are applied there. So only one unknown is there. So K uh, KK will be 1 cross 1, and K unknown will be 1, 2, 3, 4, 5. It will be 5 cross 5. So the answer is KUU, the C. Okay, question number 10 I have already solved in one of the class. We'll see again. So what it says, consider the simply supported Euler Bernoulli beam subjected to different loading. Beam 1 is subjected to at the center, beam 2 is UDL, beam 3 is linear varying load, beam 4 is parabolic, and we are using the FEM solution. So we know that when you use a two node beam element, we can correctly measure the 3 degree of equation. So for this case, we know that m is equal to ei d2y by dx square. So for this, moment will be linear. So for linear moment, we will get a 3 degree, 4 degree, 5 degree, 6 degree. So here moment is 1 degree, 2 degree, 3 degree, 4 degree. So correctly we can measure 3. Worst we can measure 6. So answer is C, that beam 4 will have a highest error, and B1 will have a lowest error. Lowest, and I think it will give you the exact solution as well. Okay, so these are the answers of the
Can
uh,
you go back to the previous question?
yeah.
Uh, no, no, before this, question number 9. So this, I think the mat KUU should be 1 cross 1, no?
KUU should be unknown, known. Yes, it should be.
I think you have just
This is
flipped
5.
it.
Known is 5 5. Okay, so answer will be reversed. So known is 5 5. Unknown is 1 1. Yeah, correct. I just made with the K and U.
Yes, yes.
Hmm. Okay. So now let's start with the week 7 questions. Uh, this time they have covered the 2 degree, I think. So let's start with the problem. So the question says, choose the correct option for the following statement. Strain is constant, but displacement varies within a CST element. So there's a constant strain triangle, you know. So since the word also says constant strain triangle, so strain is constant, but displacement is not constant. What means strain is constant here, but displacement varies, obviously. So this is correct. Then fourth order polynomial can be integrated exactly with 2-point Gauss quadrature. So 2-point Gauss quadrature can integrate up to cubic polynomial. Exactly, this we know. So this is so it is written fourth order polynomial, so this is not correct. So the 1 is correct and 2 is false, so the answer is B. Okay. So now here we have to find the shape function of the at the node 2. So I don't know, you all know how to calculate the shape function, but I'll tell you how to do it. So this is 1, 2, 3, 4, 5, 6, 7, 8. Now all are having nodes, and this is right, this is eta. For solving for n2, you have to cross the lines on other nodes like this, and now remaining is 5, 6. You can cross this by this. Now you have three lines. You have to write the equations of it. So what is the equation of this? This is eta is equal to 1 because the coordinate is there. So you can use them. Now what this equation is? For this it is xi equals to -1. And when you have to find the equation of this, you can write eta plus 1 y2 minus y1 plus 1 by 1 and xi minus 0. So this I have written y minus y1, and the equation of linear equation, when you solve it you will get as xi minus theta minus 1. So while writing, now you have all the equations of the lines which are cutting other nodes. So you can write it as n2 equals to xi plus 1 1 minus theta. Actually this is not n2. You can write the equation like this. Now when you are writing this equation, you have to find the value of this equation at node 2. So the coordinate of node 2 is given as 1 and minus 1. 1 and minus 1. So when you put it, you will get 1 plus 1, then 1, that minus 1, it will come 1, then it will be 1 plus 1 and minus 1. So when you solve it, you will get as 4. So you have to make that normalize it so that at n2 this equation will give you as 1. So we'll multiply by 4, and this is the shape function for n2. So the answer is D. Is it clear with everyone, or should I repeat? Okay, I think it is clear. Hello, am I audible?
Yes, you're audible.
Okay, if it's clear, I'll go. Question number 3, let's take it. So polynomial approximation for a field variable is given. This is the approximation. So we have to find the completeness of this function. So how to approach this question can anyone tell?
We can use the triangle, the Pascal's
Pascal's
triangle.
triangle. Okay. So what Pascal triangle say? 1 x y x square x y square x cube x square y, then x y square and y cube. So this is the Pascal triangle. We have to use it for approximating the function. So for completeness, it is said that all the degree terms should be present. So we see C naught is there, okay, this is there. X and Y is there, this is okay. Then XY is also there, okay, this is there. Then X square Y is there, X square Y is there, Y square is there, and Y cube is there, but this X square is missing. So we can't say this is complete at this point. So the answer will be only X and Y are there. So it is complete till this point only. Other are not complete. So the answer is 1. So this polynomial approximation is complete to degree 1 only. So we can write one more and check. Can ask you. Let's say we have, or I'll ask you one question. I have here this good question. Okay, so I'll ask you few questions to tell me what will be the approximate function. Let's say we have 8 noded rectangle element where 1, 2, 3, 4, 5, 6, 7, 8, and 9 is here. I'll write the Pascal triangle as well. And then x cube, x square y, xy square, and y cube. Okay, tell me the approximate function for complete and convergence. So tell me how many terms will be there in this approximate function. Hello?
Yes, you are audible.
How many terms will be there in this approximate function? This has been covered in class, na?
Word, I'm just trying to remember.
No problem. Take your time. Anyone other who remembers? Nandalan, Mahesh, Syed, Vanira, anyone?
There should be 9 terms.
Yes, there should
I
be
told you.
there should be 9 terms.
Speech.
Now
So 9 coefficients should be there.
9 coefficients should be there. Now how we should start?
So we start with x power 0 when the c0 plus
Plus
c1x
C1x
plus c2y plus c3x square plus c4xy plus c5 y square is how many? 3, 6 points now. Plus now that is for the next part. It's x cube c6 x cube plus now there are 2 x. XY term. So how do I proceed now?
Hmm.
This is the problem. So C7 x square y plus, if I take up to C8, then xy square till it's completed till xy square.
Hmm. Okay, I'll tell the
Like this
answer.
much.
When you have to move like this way, you do this, then first you have to move here, then here.
Okay.
So if you go here, then
Okay.
you have to go first to here. So what will be the answer? C naught plus C1x plus C2y plus
Right.
C3 xy
XY
C4 x square C5 y square
y square.
C6
Then
x square
x
y
square y.
C7 xy square. Now there are 8 terms done. Now the problem is if you go, you will give weightage to x cube or y cube.
Yes.
Hmm. So you can't go there. You have to go to x square y square.
Uh,
Okay. This is the thumb rule. You can't give weightage here or here.
okay.
So for that, that will be x square y
I
square.
think this was not covered in class.
It may be not covered, or he may cover later, or I don't know. Since one question was there
Yeah.
in the assignment, so I thought, or he
Yeah,
may
I
not tell
remember.
you the basic. Uh, you just have to figure it out. So I'm telling you, this is the thumb rule. You have to go this. Now one more question I'll ask. You may get confused in that as well. So let's take a rectangle element like this. One, two, three, 4, 5, 6. Okay. 1 x y x square x y square. Now tell me, 6 are there. Tell me the approximate function.
I think C0 plus C1x
C0 plus
plus
C1x.
C1x
Hmm.
plus C2x. So C2y.
C2y.
Then C3xy.
Hmm.
How many point are there? Six. So six terms. One, two, three, four, five. This is fifth term. No?
Hmm.
So C4 x square
Hmm.
plus C5
Y square.
y square.
Hmm.
One, two, three,
That's it.
five, six. Yeah,
Okay.
that's fine.
But there's a catch in this problem is that this completeness is coming. The problem is
Yes.
this: when you figure it out in the x and y direction, you see
Mhm.
this can be a square. This can be a square because you have one more node. But since this is in y direction, you have only two nodes. So it can be like this also, it can be like this also, it can be like this also. This means you have to put a linear variation in this. You can't put a
Mm.
parabolic variation in y direction. So
Okay.
this can't be applied. For
Ah,
that case, you have to go to x square y. So this
square.
will be c5 x square y. Now you see x is covering y, parabolic, y is covering linear.
Okay. Okay.
Uh, so with
Fine.
completeness, you have to see the how many nodes where are it is mentioned. If it had been here or here, then it could have
Mm.
been the different case. But you can't give y direction parabolic curve in this. So your
Yeah.
approximation will fail in here. So you have to take
Okay.
care of this as well.
Okay. Understood.
Hmm. Okay. So was this question related? Question number three. I think something's missed. Question number five. Okay. 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 The question is this. I have put it backward. So the question is this. Next question. This is the three node CST element, and we have to answer the question for 4 to 5. This is u given, this is epsilon given. So u is nothing, you if just I'll make it simplify it as phi 1 ui plus phi 2 u2 and so on. And phi is nothing, they are the n1 n2 as well only, just a way of writing as phi, but these are the shape functions only. And the epsilon is del phi 1 by del x ui plus del phi 2 by del x u1 here u2 here. Same things, del n1 by del x, del n2 by del x. Just a way of writing, they write n as phi here. They are equal. So let's solve this problem. The question what is asking is we have to find the displacement at point P located within the element. So where the P is this, and this is the one triangular element you have got with the coordinate as also. So let's start solving this. So we have to assume U. So three elements are there. So we'll take it as A naught plus A1x plus A2y. So if you want to write u1, u2, u3 for this case, you will write it as u1 is equal to a naught plus a1 x1 plus a2 y1. u2 as a naught plus a1 x2 plus a2 y2. Then u3 as a naught plus a1 x3 plus a2 y3. Just I am putting the coordinates only. So in the matrix form it will be u1 u2 u3, and we can write it as 1 x1 y1 1 x2 y2 1 x3 y3, and this will be a naught a1 a2. Okay, so what we'll do, we'll substitute the value of a naught and will this vector and put it there. So this the value of a naught a1 a2 will be inverse of this into u1 u2 u3. So we know from the problem the x1 y1 x2 y2 and y3 x3 y3. We'll substitute here. It will be 1 2 7 1 5 3 1 7 10 inverse of this u1 u2 u3. Okay, so our final solution will be a naught a1 a2, which we will get after inversing 1 1 1 with minus 1 is minus 0.2414, 0.1034, 0.1379, 0.069, minus 0.1724, 0.1034. Just I have inversed the matrix. This will be u1 u2 u3. Okay, so you have got the value of a naught. Now you, what we can do, we can write this in a different way, where we can write ux as 1 x y and a naught a1 a2, and we'll put this the value of a naught from the this matrix. I will get 1 x y, then 1 1 minus 1 minus 0.2414, 0.1034, 0.1379, 0.069, minus 0.1724, 0.1034 with u1 u2 u3. Okay, so this is 3 cross 3 matrix. Now this full since they have written in problem phi I u I, so this is u full u. So this means phi 1 phi 2 phi 3 with u1 u2 u3. So this full will be your 515253. When you multiply this with xy, you multiply this is 3 cross 3, this is 1 cross 3. So you have to create 5 transpose and then multiply, you will get it. So when you multiply this full, you will get 1 minus 0.2414 x plus 0.069 y, 1 plus 0.1034 x minus 0.1724 y, minus 1 plus 0.1379 x plus 0.1034 y. Okay, so this is the phi transpose you have got. Okay, phi transpose you have got. Now what you have to get? Okay, now you have to get in the question. You have to calculate the displacement of point P. Displacement point. Okay, point is given 4,6. So this is, so now we'll put the UP as the value as P value as 4,6. We'll put in this equation x y z, means x and y, not z. So you will get 1 minus 0.2414 into 4 plus 0.069 into 6 into u1 plus 1 plus 0.1034 into 4 minus 0.1724 into 6 u2 uh, plus minus 1 plus 0.1379 into 4 plus 0.1034 into 6 of u3. I have not done nothing, just I have substituted the value of x or y in this and multiplied with u1, u2 and u3. So you have got this solution. When you solve this, you will get 0.4484 u1 plus 0.3792 u2 plus 0.1724 u3. So this is the final solution. So you see what has been done using the shape functions of n1, n2, n3. You know the you get FEM solutions correct here, but using the n1, n2, n3, we can interpolate the function, interpolate the displacement at any point in the 2D element. So shape function acts as the interpolation function which helps us to get the displacement at any point without being it as a node. So okay, the solution what we get is this. Hello, is it okay?
Yeah.
Actually, I lost my connection. Okay, so till when it was done, did you understand this problem? Was it? You can
Yes, yes.
hear this now. So this is done. You get the displacement at point P, and the solution will give the answer as A. Now the next question, it is asking that it is connected, and it is asking the epsilon xx. For epsilon xx, we know uh, it is the summation of I is equal to 1 to 3 and del phi I by del x ui. So we have calculated u as uh, so we have calculated phi transpose, which is phi 1, phi 2, phi 3 transpose is 1 minus 0.2414x plus 0.69y 1 plus 0.1034x minus 0.172y minus 1 plus 0.137x plus 0.103y. The same I have copied from the last problem. So when you do a del phi by del x phi 1, del phi 2 by del x, and del phi 3 by del x, what you will get? You will get only the x terms. It will be 0.1034 and 0.1379. So when you use this in the epsilon uh, formulation, it will be del phi by del x u1 plus del phi 2 by del x u2 plus del phi 3 by del x u3. So substituting, you will get 0.2414 u1 plus 0.1034 u2 0.1379 u3. So this is the answer for epsilon. So the answer is D. So this is the way you solve a 2D problem. Means you till now you have got the single term of x and you are doing the interpolation. To solve 2D problems, you have to work in x and y simultaneously, and this is the way to solve the 2D problem in an FEM. So for today, I have this only. So today I have covered the assignment 6 problems, and I have given a head up for the week number 7 assignments. The questions are similar to this. You will get to know, and you will be able to solve now. So if any other problem with today's class or any lecture problem, you can ask me now.
No, it's fine. But I have one very general
Yeah,
question.
tell me.
Means during the examination,
Hmm.
will we be allowed to do this calculation with calculator or with hand?
I think calculator will be allowed, but in the
Okay,
end you have
then
to
it's fine because
you will get the guidelines.
cal- uh,
You have to give it a center, na. You have to go to center and
yes, yes, I have to. I don't remember. Means during matrix
uh,
method of structure analysis, I don't remember that if calculator was allowed or
okay.
not.
I'll confirm and let you know in the next class. But I think the calculator will be allowed.
Yeah, for this it should be allowed.
हाँ हाँ
Means
नहीं, it should be
a lot
allowed.
of calculations are there,
हाँ
so
हाँ, it will be allowed.
Sir, online calculators are available, I guess.
Okay, so this is
Online calculator is only available,
Online calculators, not the physical
not the
ones.
physical ones.
No.
okay. So you have to
Sir,
get
I
it.
have a question.
Tell me.
So, why the problem solving, these interactive sessions are not available in the, so recorded sessions are not available at the site?
No, no, it is
It's available,
it's
no?
available on
On
YouTube.
YouTube.
I'll show
So,
you.
YouTube.
Yeah, I'll show you. It's all available in the YouTube.
Oh, okay, sir.
You are not getting the link. That sheet is be shared with you, na?
So, which sheet?
Uh,
Sheet?
sheet is not shared with you.
She hasn't joined the group.
Shouldn't join the group. Yeah, if not joined, you directly search here FEM NPTEL TA sessions. See, I have uploaded everything. You type this. My name is the Nikhil Gupta. You will get the
Okay, sir.
videos. And I have shared in the Excel sheet also. I don't know why you are not getting that. But if you still don't get it, you directly type FEM NPTEL TA session. You will get it.
Okay, sir.
I
Thank
have
you, sir.
uploaded all the lectures of it. Last class I have shifted to Sunday, so no one joined. But still, you can have the session video. You can check it out.
Okay, sir.
Hmm.
Thank you, sir.
Anything else?
Nothing from my side. Thank you.
Okay. Anything problem in the lectures going on?
Lectures are fine till now.
Okay, that's good.
Yes.
Okay, that's all for today.
Okay.
I'll,
Thank
I'll
you.
wait for 5 more minutes if anyone has doubt. Thank you.
Sir,
Yeah, tell me.
sir, you were talking. So you were talking about one link to join, no, sir? So what is that? So I have no
No,
idea.
I don't know. Means this NPTEL people may have shared you with the with an Excel sheet.
Okay,
You
sir.
don't have that Excel sheet.
No, sir.
No, you have to ask
So maybe
someone.
I have to check my mail, sir.
No, no, I can't do it. You have to write
Okay,
a mail to NPTEL, or you can ask some fellow mates how they are getting it.
yes, sir.
But means there must be. I'll see in that. Wait, is it there or not? So I'm opening the where the videos are there.
Excel sheet is regarding what?
What?
Regarding what is that Excel sheet?
One Excel sheet is being shared with you where you can see the YouTube videos which are uploaded of this session.
Okay, okay.
Do you have that Excel sheet? Is it shared with you?
No, I
That
don't have.
don't have. No, you have to search it, or otherwise, I don't know why you don't get. You must have missed something, some mail regarding that. But that in the beginning it must have been shared. Otherwise, you do one thing: you type that FEM NPTEL session. For time being, you will get in that sheet only. This link is there, and the also you have that access to this question and answer one, na? Avanira.
So question. So
This
I didn't
Google
get
forum
you.
you have the access.
No, sir.
You don't have to wait.
So actually, I didn't understand, sir.
Wait. I'll share my screen. Do you have access to this Google forum?
Yes,
These
sir.
mails you are
Yes,
getting.
sir. Yes, sir.
See, I have sent a mail link for class notes and videos.
Okay, sir.
This mail, you must have got this mail.
So maybe, sir, maybe I skipped it. I have to check again,
So
sir.
in that I have given the link for one of the video,
Yes,
and
sir.
also I have given the drive link for where I am uploading the course means whatever I'm writing. So
Okay, sir.
both links are there. If not, let me know next time. I'll mail you again. But in that mail, you can directly see. Check it out. This group is there, na discussion forum for FEM. You for that you have to go
Yes,
there.
sir.
This site, you know.
Yes, sir.
Your question and answer is there. Go to
Yes, sir.
continue,
Yes, sir.
and you will get it. There one mail you will
Okay, sir.
get from this, and you can directly go to both this.
Okay, sir.
Okay.
Thank you, sir.
Okay. So if you don't have doubts, you can leave the class.
Thank you, sir.
Thank you. Nanlan and Mahesh, do you have any doubts?
No, no,
Okay.
not now.
Okay. Thank you. You can leave now. Yeah, tell me.
One pipeline, so there is first function integration of the second function to be my first function, the second function of first function integration of second function.
Any doubt you have, Nanlal?
Sir, actually, what I am telling now, this group I have not joined, and that link is missing in my mail, sir. Whether I can receive that link once again?
Okay, I'll tell you. Wait. Do you have access to this page? Wait, just coming. Do you have
I have to go to
do you have access to this?
how to access this one?
Where do you watch videos?
I will watch either on mobile or desktop.
Okay, can you share me and show me how you watch it?
Actually, I will go in my Gmail and click the link, and link will connect to this video, sir.
Direct videos they open. You don't have access to this page.
I think so, sir.
Oh, this is general link, na. This is the online lecture of 25. These are where you get the videos you see and the assignments.
Okay. Yeah, this is once we join the group, then it is possible, no?
Which group you are talking about?
Just a common group you told, no?
This one? If you are enrolled, you will be able to join this directly.
Okay, I will try, sir, once
How
again.
you try? Otherwise, if you have access, you will be having the access with this page.
This page I have
You have
access,
access,
sir.
no? Now there
Yes,
is a
yes, yes.
option Q&A.
Actually, that swab NPTEL courses, I'm getting this,
You are
sir.
getting this? Yeah. Did you see that Q&A?
Q&A is there,
Q&A.
sir.
You
Okay.
open that Q&A.
Yeah, yeah, yeah.
Did you see a mailbox?
1 minute, 1 minute.
Uh,
This is final. Okay, I will go Q&A. There
uh,
is continue and close, sir. Continue, no?
continue.
Okay, I'm getting in my desktop that.
Uh,
Okay, okay, okay. Here I got reschedule of TA class, sir, from you.
Similarly, now you see the down Nikhil Gupta mail is there where you can see link of class notes and video.
Okay, okay, okay. From here I have to see, no?
Means if you don't have that Excel sheet, you can go to this
Yes, sir.
mail, and one of the
Okay, okay.
you video link is there. So if you open this, you will go to my channel, and there you can see other videos as well. Also have I have attached the Google Drive link where you will get
Okay.
the notes as well.
Okay, sir. Okay, okay. I will try my.
You will get
Uh,
from here.
okay, sir. Okay.
Okay.
Thank you. Thank you for helping
Let
me,
me
sir.
know if you have doubt again.
Yeah, yeah, sir.
Okay.
Actually, sir, now
Tell me.
here what I want to tell you, sir.
Hmm.
Now we are about to end of the seventh week.
Yes, yes.
Questions, how will be there in the exam now? One sample piece whether can be shared,
The question will be same as the assignments.
same as the
Means same
assignment.
means the type will be same.
At least one sample paper can be shared. It will be easy for us to assess the quality of that exam.
Last year papers we don't have it, so I don't know you will get it. But I'm telling you these will be same. The quality will be same as the assignments.
Okay, sir.
Not
Okay,
that
sir.
too much tough, and it will be like you see na assignments are not that too much tough, so it will be same. Quality will be
Okay,
same.
okay.
Okay.
Okay, thank you.
Thank you.